Hi friends, I am Subhajit Paul, Assistant Professor of Government Engineering College, Ramgarh. In last class I have discussed about the combinational circuit and the sequential circuit very briefly. Today I will discuss about the half adder and full adder. Here are the learning objectives, whatever we covered today. The first is the introduction, then the definition of half adder, then study of its truth table, circuit diagram, block diagram, etc. Then the same things on the full adder, definition, truth table, circuit diagram, Boolean expression, and lastly we discussed very shortly that how a full adder is made with the help of two half adders. Okay, let's start. Here you can see that the definition written here, a combinational circuit which adds two 1-bit binary numbers is called a half adder. Basically, adder, the function of the adder is adding. Okay, we all know the add. Now, before going to the lessons, I think you all know the addition in binary. That means there is a little bit difference in binary addition and normal algebra in decimals. In normal algebra, if we add 1 plus 1, it gives 2. But in binary addition, if we add 1 plus 1, then it gives 1, 0. That means 0 for sum and 1 as a carry. And 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1. These three are the same. Now, 1 plus 1 gives 1, 0. So, very similarly, if you know the conversion, decimal to binary conversion, then you can simply understand that 1, 0 is nothing but the representation of the decimal number 2. Okay. So, the definition, I have already discussed that addition of two binary digits is most basic operation performed by the digital computers. The most basic operation, no doubt, is the addition of two binary digits. The simple addition consists of 4 possible elementary that summarized in the table, and from this truth table, this is basically the truth table 0 0 0 1 1 0 1 1. As we know that if we have two combination, then the maximum output must be 4. That means 2 to the power n numbers. Okay, so let's check the truth table first. That 0 0, in this case we get as a sum 0 carry 0, 0 1 sum 1 carry 0, 1 0 sum 1 carry 0, 1 1, in this case we get sum 0 but carry 1. Okay, so we know the truth tables of the basic gates. Just simply look that for two input XOR gates 0 0 1 0 1 1 0 1 1, look at this sum column. Okay, that represents simple a XOR gate truth table. Just omit it and just take the sum. So it is just like a XOR gate. And for the carry, just omit the sum. Look at this carry out column. What is this? This is basically a AND gate truth table 0 0 0 0 1 0 1 0 0 and 1 1 1. So from this we can conclude that the sum column resembles like an output of the XOR gate. The carry column resembles like an output of the AND gate. So this is a basic two input and two output combinational circuit. Here is the block diagram A and B, and the output sum, and here is the output carry. So from this truth table we can simply conclude that the Boolean expression must be sum is equal to A or B, because from this sum column you can already got these things, and for carry AB, that means A and B. So from this Boolean expression simply we can express it or realize it by the logic gates, one AND gate for carry and one XOR gate for the sum. XOR means we also know that the A XOR B means A bar B plus A B bar. This is the expression, simplified expression of the XOR gate. So if we put these things in the Carnot map, we can also get these two equations. Now, before going to the full adder, I must say that there are some limitations of half adder. Now what is this? A half adder can add, if you say the bits, input bits A0 and B0, then a half adder can add A0 and B0 to produce S0 and C0. However, the addition of next bits requires the addition of A1, B1 and C0, that means the previous carry. The addition of the 3 bits is not possible in the half adder. But in our digital circuitry, we mostly need to add multiple number of bits. We are not limited with these 2 bits, isn't it? So we are more concerned about the full adder because it can add more than 2 bits. Okay, now let's see that what is full adder. A full adder is a combinational circuit. Here look that it is a combinational circuit. 3 input A, B and C in. C in means carry from the previous stage, and output carry out and sum out. So a full adder is a combinational circuit that forms arithmetic sum of the 3 input bits. It consists of 3 inputs and 2 outputs. To overcome the drawback of an half adder circuit, we develop a 3 single bit adder circuit called full adder. It can add 2 1-bit numbers A and B and 1 carry in. Now let's concentrate on the truth table. Here these are the 3 inputs A, B and C in. So 3 inputs mean maximum 2 to the power n, that means 2 to the power 3 is equal to 8 possible output inputs, input combinations, that means 0 0 0 0 0 1, likewise 1 1 1. Here the funda is also same here, that means output sum and carry. 0 0 0, in this case we get sum as 0 and carry 0. For input 0 0 1, we get sum as 1 and carry 0. Here the same funda is applied, that means for 1 1, for if you add 1 1, we get 0 as a sum and carry 1. Just look at this last combination 1 1 1. If we add 1 plus 1, then we get sum 1 and extra carry. Then again if you get 1 1, then the carry bit is also 1. Okay, so from these truth tables, if we put this output combinations with these inputs different in a different format. Now for sum, if we put ABC with the sum output in Carnot map, we will get A XOR B XOR C in. Just like for carry, if we put in Carnot map as an input A, B, C in and carry, we will get C out, AB plus AC plus BC. So from this expression, if we draw the circuit diagram with the basic gates, we get these arrangements. Okay, so this is the simple circuit diagram by using simple basic logic gates. Now this is the alternate representation of full adder. Here 2 half adder is added. That means a full adder circuit is constructed, which is shown here. Here some output from the first half adder is connected as input of the second half adder, and the carry from the previous stage C in is connected as the second input of the second half adder. Finally we get the resultant sum from the second half adder and carry out by ORing the 2 half adders C1 and C2. That means this is the final carry out